This is Unit 5, Day 4, Special Right Triangles, and it's Day 2. I already went through the warm-ups. I'll just explain it really quickly, but I'm not going to spend too much time on it since that's not really the focus of the lesson. I started with 8 divided by the square root of 3. I needed to rationalize my denominator to get that square root out of the bottom. So what I did was I multiplied it by the square root of 3 over the square root of 3, which again is the same thing as 1, because if you divide anything by itself, it's 1, so it's not really changing our number at all. It's just multiplying by 1. It changes the way that it looks. Then when you multiply straight across, you get that 8 times root 3. You can't really do anything with that because you're multiplying real number or regular numbers with root numbers, and you can't combine those. But then on the bottom, we can combine these because they're both under a radical. Root 3 times root 3 equals a regular 3. This is my final answer. I cannot simplify it anymore. Again, on the next one, same idea. I'm rationalizing my denominator, but by this one, I am actually multiplying by root 2 over root 2, and it's just changing the way that it looks. So my final answer here is 7 times the square root of 2 over regular 2, because those 2's on the bottom will just turn it, the root 2's will turn into a regular 2. Last one here. All of these things are being multiplied, and just so we're aware, that's 6 times the square root of 3. Those things are being multiplied too. Since I can't really multiply this 6 with anything under a root because it's outside of a root, it's kind of just going to have to be put down on my next step. Now those 2 root 3's, these can be multiplied because they're both under a square root. So I multiplied them and I got the square root of 9. The square root of 9 is just 3, so as you can see on my next step, I did 6 times 3, and I got 18. Okay, next. It wants us to label the missing sides of each triangle. This is a 45, 45, 90 triangle. Basically what it's asking for here is the template. What is our template for 45, 45, 90 triangles? If it's 45, 45, 90, our 2 legs are exactly the same, and then our hypotenuse is x times the square root of 2. Over here, I know my hypotenuse is double my smaller leg. Now, it's got a y there, so we're just going to use the y, but this would be the same thing as 2y. It's twice as big as y. This one over here would be y times the square root of 3. So those are your 2 templates. Usually this one over here is, it's an x instead of a y, but we're going to go with the y for that one. Okay, find x. So if this one's 22, that means this is also 22. And using our template from above, we have x root 2 for the hypotenuse. So over here, it's going to be 22 times the square root of 2. So again, we just have to use that template. Over here, we have 13 as the hypotenuse. Now, it's tougher to go backwards to get that x, so we're going to actually have to set this up. The template said that this term was going to be x root 2. So 13 equals x times the square root of 2. That means I'm dividing by the square root of 2 on both sides. So 13 divided by the square root of 2, I can't leave that as an answer. I have to rationalize that. But these 2's, or square root 2's, will cancel out. We'll just have x equals 13 over the square root of 2. I'm going to multiply by square root of 2 over square root of 2. And if I multiply that out, the top multiplied out would be 13 times the square root of 2. The bottom multiplied out would be a regular 2. I'm going to have to leave my answer like that because 13 over 2 doesn't simplify. And that's the same thing for down here. 13 root 2 over regular 2. Next one, again, my template. I'll show you that one just real quickly here. My template looks like this. If you need to pause that and write that down, that might help if you're watching this video. I know that my hypotenuse is double the smallest leg, so this is going to be 30. And this side down here, my longer leg is my shorter leg, 15. That's supposed to be a 15. Times the square root of 3. That's it. Over here, I know my longer leg is my short leg times the square root of 3. Since there's already a square root of 3 here, we can basically just get rid of that and say my short leg is just a regular 14. If that's 14, then this would be 28. And we're done with that one. Moving on to the next one. Now my long leg, my hypotenuse, is a weird looking number there, 42 times the square root of 3. I know that my small leg here is going to be half of that number. If I'm dividing it by 2, I only have to divide the outside part by 2 because that square root is kind of protected there. So it's going to be 21 times the square root of 3. That would technically be half of this. The square root of 3 doesn't have to be cut in half, just that outside number. Now, to get this bottom part, we have to multiply all of this by the square root of 3. So we get 21 times the square root of 3 times the square root of 3, which is the same thing as 21 times regular 3, because square root of 3 times square root of 3 is regular 3. Well, 21 times the square root of 3 is 63. So by the way, yeah, on that one, even though it wasn't asking for what this was, you had to find that in order to get to the x. So sometimes you just have to find all the parts of the triangle to get what you need. Moving on to the next one. If that's 23 root 2, this is 23 root 2. I know it's not asking for that, but it's really easy, so I just did that. And then down here, we got to realize that it's whatever this is times the square root of 2. So it'll be 23 times the square root of 2 times the square root of 2, which is 23 times regular 2, which would be a 46 for that one. That side length would be 46. Determine the length of a leg of a 45, 45, 90 triangle with a hypotenuse length of 18. This is a drawing. It's not that difficult of a drawing. We'll say those are the same. These sides are the same. It's a 45, 45, 90. This would be 18. This is a right angle. That's my drawing. So if that's 18, I know that the hypotenuse of a 45, 45, 90 triangle is, so 18 equals x root 2. If I divide by root 2 on both sides, I get, well, I'll have to rationalize it, I guess. So I'll do root 2 over root 2. So I'll have 18 root 2 on top, and on the bottom I'll have a regular 2, which is the same thing as 9 root 2. That's my final answer. Next one says, Mr. Waltner has a square garden in his backyard. He wants to pave a path from one corner of the garden diagonal to the other corner. One side of the garden is 24 feet. What is the length of the diagonal path where he wants to pave? So if he has a square garden, if you're thinking about this, square garden. I don't know why it's chose red, but we're going to go with that. Okay. And it wants a path from one corner to the other. That would look like that. One side of the garden is 24 feet. So if it's a square, that means this one is also 24 feet. And what we have here is a triangle, and it's specifically it's a 45, 45, 90 triangle. Let's see if I can show you a little bit better here. It's not going to work. Okay. Oops, that's 24. That's my triangle, though. You can see what I'm talking about here. That's my triangle. It's a 45, 45, 90 triangle. So if that's 24, that means that this inside piece would be 24 times the square root of 2. And that's just coming from my formula up top. So you could do that Pythagorean theorem if you wanted to as well. You'd get the same answer. A test question asks you to find two side lengths of a 30, 60, 90 triangle. You know the short leg is 6. Okay, I'm going to start drawing this right now before we get too far in. So short leg is 6, but you forgot the special formula. Oh, shoot, we forgot the special formula. So what should we do? If it was me, I would say, okay, well, what if this was a equilateral triangle? Because we know that an equilateral triangle cut in half is just a 30, 60, 90 triangle. So this would also be 6. This would be 6 as well. So would this. Oh, no, I'm sorry, that would be 12. I messed that up. This would be 12 because it's equilateral. Since this whole bottom side is 12, that would be 12. This would be 12. Now I could use my Pythagorean theorem with the 12 and the 6 to get that missing side. And that would just, well, you could do the Pythagorean theorem to figure it out, but we know from the 30, 60, 90 triangle template that it's going to be 6 root 3. And we are done. Looks like there's a worksheet for today. Thanks for watching.